Turning back time, cellular reprogramming, and the science of reversing aging. What if aging was no longer a one-way street? What if your body had a built-in reset button? Not a metaphorical one, but a biological mechanism that could take your old, tired cells and make them young again. For decades, this sounded like pure science fiction, but thanks to one of the most astonishing breakthroughs in modern biology, it's starting to look more like science future. At the center of this revolution is a soft-spoken Japanese physician-scientist with a profound idea and a Nobel Prize to prove it. His name is Shinya Yamanaka, and his discovery may fundamentally change what it means to grow old. Chapter number 1, the discovery that changed everything. In 2006, the world of biology was shaken by a quiet revolution. Shinya Yamanaka, working out of his lab at Kyoto University, announced a discovery so groundbreaking it would soon earn him the Nobel Prize in Physiology or Medicine. He had found a way to take a fully mature cell, say a skin cell from an adult mouse, and rewind its clock. By introducing just 4 genes into the cell, Yamanaka could turn it back into something resembling an embryonic stem cell, young, flexible, full of potential. These genes, OCT4, SOX2, CLEF4, and c-MYC, came to be known as the Yamanaka factors. Let that sink in. We're talking about reversing the identity of a cell, unraveling years, even decades of biological aging. It was as if a tree could turn back into a sapling. Scientists were stunned. For the first time, aging was not just something that happens to us, it was something that might be undone. Chapter number 2, Beyond Stem Cells, Rewriting the Code of Aging. At first, Yamanaka's discovery was primarily seen through the lens of stem cell therapy. If we could generate patient-specific stem cells, maybe we could regrow organs, repair nerves, or treat degenerative diseases. But a second wave of researchers saw something even bigger. They asked a radical question: what if we didn't just use reprogramming to grow replacement tissues? What if we reprogrammed the tissues we already had, right inside the body? This was the birth of a new field, cellular rejuvenation. You see, your cells don't just get damaged over time. They remember that they're old. That memory lives not in the DNA sequence itself, but in the epigenome, the complex system of chemical markers that tells genes when to turn on or off. Over time, this system becomes noisy, disorganized. It's like a symphony where the sheet music is smudged and the instruments are out of tune. That disorganization is one of the reasons cells stop functioning properly as we age. What Yamanaka discovered was essentially a way to clean up the sheet music. The Yamanaka factors can reset these epigenetic markers, allowing cells to return to a more youthful state, not just in how they look, but in how they function. Chapter number 3, the mouse that got its vision back. One of the most iconic demonstrations of this power came in 2020. At Harvard Medical School, Dr. David Sinclair and his team used partial reprogramming, briefly exposing cells to Yamanaka factors, to reverse aging in the eyes of blind elderly mice. Yes, blind mice regained their vision. Not only did their retinal cells begin functioning like those of younger animals, but the team was also able to show that biological age, as measured by sophisticated epigenetic clocks, was actually reversed. It wasn't just preservation, it was rejuvenation. Chapter number 4, a new race begins. The longevity world lit up like a Christmas tree. Startups began forming, billionaires began investing, scientists began dreaming. One of the biggest entrants was Altos Labs, a secretive but well-funded biotech startup backed by Jeff Bezos, along with several Nobel laureates and world-class scientists. With more than $3 billion in funding, Altos is betting big on reprogramming as the next great leap in healthcare. Another major player is Calico Labs, founded by Google's parent company, Alphabet. Their mission is nothing less than to solve death. They too are exploring reprogramming, alongside other life extension technologies. What was once fringe biology is now the next frontier of Silicon Valley. If you like this video, please let us know by hitting like button below, and please don't forget to subscribe. Chapter number 5, the promise and the peril. Of course, there's a catch. Reprogramming is immensely powerful, but also potentially dangerous. If you push cells too far, they don't just become younger, they become pluripotent, meaning they can turn into any cell type. That includes cancer cells. In other words, full reprogramming is like turning a car into raw steel. You can build something new, but you might also crash it in the process. That's why the focus today is on partial reprogramming. Short, carefully timed exposure to the Yamanaka factors that restores youthfulness without erasing the cell's identity. Think of it as cellular Botox, but at the molecular level and potentially permanent. Still, researchers are moving with caution. Dosage, delivery, timing, it all matters. Too much and you risk chaos. Too little and nothing happens. Chapter number 6, From Mice to Humans. So, can we use this technology in humans? That's the million-dollar or maybe billion-dollar question. Right now, most of the work is still in animal models, but early results are promising. Mice treated with partial reprogramming show improved organ function, better muscle strength, even increased lifespan. Some researchers are developing gene therapies that deliver the Yamanaka factors directly into cells using viral vectors, like tiny delivery drones for genetic instructions. Others are working on small molecules or drugs that can mimic the effects of reprogramming, offering a more controlled, reversible method of rejuvenation. The first human clinical trials are still on the horizon, but they're coming. And when they do, they'll mark a turning point, not just in medicine, but in human history. Chapter number 7, Ethical Earthquakes. With all this potential comes an avalanche of ethical questions. If we can reverse aging, who gets access? Will it be a tool for global health or a luxury for the elite? What happens to retirement, to pensions, to the very rhythm of life? Do we want to live to 120, 150, or even longer? And what does youth really mean if it's no longer tied to time? Some critics argue that this pursuit of longevity is narcissistic or unnatural. Others see it as the logical next step in medicine. Instead of treating disease one at a time, tackle the underlying cause of nearly all of them, aging itself. As Dr. Yamanaka himself has said, "My goal is not to make people immortal, but to help them live healthier, longer lives, without suffering." And really, isn't that the point? Chapter number 8, The Road Ahead. Right now, we're in the early days. The science is dazzling, but we're still learning how to safely translate it into medicine. Over the next decade, expect to see preclinical trials in larger animals showing long-term safety and effectiveness. New delivery systems, including lipid nanoparticles and engineered viruses. Combination therapies that use reprogramming alongside gene editing, stem cells, or immune modulation. Startups offering diagnostics based on epigenetic aging clocks to track progress. And maybe, just maybe, the first reprogramming treatments entering human trials. It's not a guarantee. Science doesn't move in straight lines. But we've entered a new territory, one that would have seemed impossible just 20 years ago. Chapter number 9, From Kyoto to the World. Shinya Yamanaka continues to inspire the field he helped create. Humble, thoughtful, and deeply ethical, he remains a strong voice for balance in the pursuit of power. His discovery didn't just win him the Nobel Prize, it launched an era. From a single lab in Kyoto, a ripple has grown into a wave, spreading across research centers, biotech hubs, and medical schools around the world. We're still early in the story, but we now know that aging isn't destiny. It's a process, a program, one that we may soon learn to control. And if we do, we'll live in a world where people don't just live longer, but better. Where health span, not just lifespan, is the new gold standard. Where grandparents run marathons and memory doesn't fade with time. A world where growing older doesn't have to mean growing old. If you like this video, please let us know by hitting like button below, and please don't forget to subscribe.